Hey everyone, welcome back to the Workplace and Apprenticeship 10 videos. In this video, we're going to look at lesson 4 from chapter 6, which is talking about similar triangles. So in order for two triangles to be considered similar, one of the two following requirements must be true. So either 1, any two of the three corresponding angles are congruent, or 2, one pair of corresponding angles is equal, and the corresponding sides adjacent to those angles are proportional. So in our first set of triangles here, I want to introduce to you a new symbol. This little wavy sign here means similar. So the little wavy sign means similar. So that's saying that these two triangles here are similar. And this one here is using that first property. So we know two angles from each triangle, and those corresponding angles are equal. So we have 92 and 92 and 18 and 18. It doesn't matter what the third one is, because using the property of the sum of the interior angles of a triangle, we could easily find the third one, and we would get the exact same answer. Because for both cases, you take 180 degrees, subtract 18, subtract 92, and you get the exact same answer. So this here is when you know two angles. So this set of triangles here are similar, and that's using our second property here. So it says one pair of corresponding angles is congruent. So that's 92 degrees here, 92 degrees there. And then the corresponding sides adjacent, which means next to or touching, those angles are proportional. So that's using our side going up and down here. So this 26 and 13, and then using this bottom is 16 and 8. So there are the two sides that create that angle. So you either need to know two angles or one angle and both adjacent sides. So now we're going to apply this information to help us find missing information in a triangle. And this one here will be example number 1 in your notes. So given the two triangles below, we're going to find the length of n. So first of all, nowhere in this question and nowhere is it indicated that these two triangles are even similar. So if they're not similar, then there's no possible way we can find out what the missing length of n is, which is right down here. So step number 1 is actually to figure out if they are similar. And then, assuming that they are, we could use those properties above to actually solve for our missing side. So step number 1, are they similar? And this one here might not be quite so obvious, but yes, these two triangles are similar because they have two corresponding angles that are equal. And we know that because we're using the exact same symbol in each of those corners. So we have an x and an x, which means that they're the same angle. And then we have this little arc here and an arc up here as well. So we know that these are similar because they have two pairs of congruent angles. So we can say yes, since angle C is equal to angle N, and angle B is equal to angle M. So we have two pairs of congruent angles that are equal. So then we can go ahead and use what we know about similar triangles and even just similar polygons to find our missing side here. So step number 2 is what we're going to do is we're going to find the scale factor, and that'll help us to figure out how we reduce the 7 to get our smaller dimension. And then, so in order to use the scale factor, you have to remember you have to use sides that are corresponding. And in order to find your scale factor, you have to be given both of those dimensions. So here in our larger triangle, here we're given the side A is equal to 5 inches. And then the corresponding side here is L is equal to 2 inches. So those are corresponding sides, and we're given both of those dimensions. So if you want to, we can label this one here as our new triangle, this one here as our old, for the sake of using our scale factor little equation there. So you know your scale factor is equal to your new over your old. So it'll be 2 over 5. So then step number 3 is to find the missing side. And that's going to be using what you know about scale factor. So that your scale factor is equal to your new dimension over your old dimension. And in this case here, we found our scale factor to be 2 over 5. So we're going to put that in for our scale factor. And then we're going to use the new and old for this side N and side C. So in the new triangle, that there is side N. So you have 2 over 5 is equal to side N over your old, which in this case is 7. Then you have two fractions that are equal to one another. So you're going to use cross multiplication to solve. So you have 2 times 7, which is 14, is equal to 5 times n, which is just 5n. Then we want to get n by itself, so we're going to divide by 5 on each side. And we would find that we would get 14 over 5, or because decimals can be a little bit more useful than fractions, that's also equal to 2.8 inches. So side n is equal to 2.8 inches. So just as a quick recap from this question here, if you're given two triangles, if you're not told that they are similar, then you first need to determine that. Because if they're not similar, then you can't use the properties that we discussed in this lesson. So when you've confirmed that they are both similar, then you need to find the scale factor and use the scale factor to find those missing dimensions. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.